Okay. All right. We'll stick with that. Okay, so number 10. Me too. Okay, here we go. Okay, so here's what we know. We've got mass 1 over here, mass 2 over here. They are connected by a rope. It's frictionless, which means really we don't need to worry about normal force, perpendicular force. All we got to worry about is parallel forces, right? Okay? So if we do that, I actually have the work written out for this somewhere on one of these sheets of paper. That's yours. Hello, where are you? You guys are way more patient with me than you should be. Just had it. I was working on it in the back. Damn it. Batman.
Did you accidentally give it to your wife and like
As payment for croissants, here's some AP Physics stuff you don't care about. Is it still sitting at that back table, maybe? I don't know. All right, whatever. Okay, so let's see. So if you find your FG parallel over here, you get, where's the actual problem? Looking at it will help me. So mass 1 was 6 kilograms. Did you just say it? What is it? 50.92, thank you. All right, and then I remember this one is 58.8. All right, are we all good up to there? All right. So part A says, so is everybody okay with why I'm not worried about my perpendicular components?
Yeah.
And everybody good with why I am concerned about parallel components? Okay, so part A says find the acceleration of the system. So net force equals net force. So my total mass is 18 kilograms times acceleration equals 58.8 minus 50.92. And solve for your acceleration, and it gives you whatever I said the answer was on the sheet. Specifically 0.438. Cool? Yeah. Any problems with that? Okay, B, find the tension in the rope. So you guys tell me, we just did one just like this. What's the easiest way to find the tension in the rope? Pick one of the two blocks, right? So let's use block 2. Net force equals net force. So let's see, the mass of block 2 is 12 kilograms. The acceleration we just found at 0.438. That's got to equal FG parallel, which is 58.8, minus the tension. Right? Because there's only two forces on block 2, gravity and tension. Follow? Yeah. All right, so solve for your tension, and you get, whatever I said the answer was on the sheet, 53.5 newtons. Cool? All right, let's do part C, because this was, I've seen these problems before, and I think it's the only one I've given you like this. So find the force Roy would need to apply to mass 1, parallel to the ramp, to make the rope go slack. This is important. This is going to be a thing that comes up again. All right? So if the rope is going slack, basically that means that your tension is 0, right? Okay? So there are a couple ways of doing it. Option 1 is
find the acceleration of 2.
Yeah. So if the tension is 0, then how many forces are going to be on block 2? Just 1, right? Does that make sense?
Yeah.
Okay, so let's figure out how fast block 2 would slide with no tension. Okay, so block 2 has a force of 58.8 newtons. And if the tension is 0, that's it, right? So, acceleration equals net force over mass. So our net force is 58.8 newtons. Our mass is 12 kilograms. Divide this and you get 4.9 meters a second squared, I think. Is that right?
Yep.
Does that make sense? Yep. So now the question is, they're attached by a rope. So I need to make sure that block 1 is moving up the ramp with at least that much acceleration, right?
Yep.
Does that make sense?
Yes.
Because they're moving together, right? So in order to get the rope to go slack, I sort of want block 1 to be moving at least as fast as block 2, if not faster, right? So that the rope doesn't sort of need to pull block 1, right? Okay? So for block 1, we can do net force equals net force. My mass is 6 kilograms. Guys in back, please. The acceleration is 4.9. That's got to equal the force of Roy minus FG parallel. And solve that. And so it gives you, what is it? 80.3. 80.83. I'm going to keep guessing.
80.3.
Thank you. I should stay home. All right. Everybody good with that? All right. Should I do D? Yeah, I see a few of you nodding. Okay. So D says, suppose we replaced block M1 with a new block. What must its mass be if the tension in the rope is 80 newtons? So, thoughts about how to go about this one? The acceleration would have to be the same because they're, okay, so the tension isn't 0, so we know they're moving together, so they have to have the same acceleration. Okay? So the problem is we can't look at the whole system because I don't know my total mass, right? And I don't know the acceleration, so there's 2 unknowns there. I can't look at block 1 because I don't know its mass, but what about block 2? Yeah, for block 2, I know all of my forces and the mass, right? So to do part D, you're going to go, all right, well, block 2 is here. I know that it's got an FG parallel of 58.8 newtons, right? And the problem tells us the tension. It's 80 newtons, right? So acceleration is net force over mass. So my net force is, we probably should call this negative 80, right?
Yeah.
So the net force turns out to be negative, 21.2?
Yep.
And our mass was 12 kilograms. So this acceleration gives you a number that I...
Negative 1.76.
Negative 1.76. Thank you so much, Josh. Meters per second squared. Is everybody good with that? Follow? Okay, so now we got to take that acceleration and apply it to the other block. So our other block has 2 forces on it. It's got a tension of 80 newtons and an FG parallel, which is equal to M times G times the sine of, is that one 60 degrees?
Yes.
Follow? Negative, I guess, right? So now we can do net force equals net force. So M times negative 1.76 equals 80 minus M times 9.8 times the sine of 60. And then solve for your mass. Net force equals net force is like that's totally our wheelhouse this chapter, right?